Part 5. Hashing. We have seen searches that take O of n and searches that take O of log n. But what if I told you there is a way to find anything in a single step? Not a search, a teleport. The secret is a hash function. You give it any key, a name, a URL, an ID, and it scrambles that key into a number. And here is the crucial part. The same key always produces the same number. Always. Then we use that number as an address. The name Anna hashes to say 7. So we store Anna's record directly in bucket 7. Later you want Anna back? Just run the hash again. It points straight to bucket 7. No scanning, no comparing. One single hop. That is O of 1. And it is the magic behind Python's dict and set. But there is a small wrinkle. Sometimes two different keys hash to the very same bucket. We call that a collision. Anna and Tom both land on 7. We handle it gracefully. The bucket simply holds a tiny list, a little chain, and the colliding keys line up there politely. As long as collisions stay rare, your lookups stay almost instant. And what keeps them rare? Two things. A good hash function that scatters keys evenly across the buckets, and not letting the table get too crowded, which we measure with the load factor. Once it fills past about 70%, the table quietly grows and rehashes everything into a bigger home. So a hash table never really searches for your data. It computes exactly where the data lives and walks straight to it. And that one idea quietly powers dictionaries, sets, caches, and database indexes just about everywhere.